Hello everyone. Today we will discuss how to find the Laplace transform of given f of t when that f of t is composed of different subfunction. See, in our given example, f of t has two different functions, e and minus e. The function is e when t lies between 0 to a by 2 and minus e when t lies between a by 2 to a, where f of t plus a is equal to f of t. We have to show that Laplace transform of f of t is equal to e by s tan hyperbolic as divided by 4. See here, our limits from 0 to a by 2 and a by 2 to a means the period, our period is a here, means t is equal to a. The given function is periodic with period t is equal to a. We have this result. Next we have to change the limit here. After that we have to take the functions one by one. L of f of t is equal to 1 divided by 1 minus e raised to minus st. For the first function, 0 to a by 2 is the limit, e raised to minus st e into dt plus integration from a by 2 to a e raised to minus st into minus a into dt. Now we have to integrate to this integrals. We have 1 divided by 1 minus e raised to minus t value is a here. I will substitute t as a. Next is e is constant, keep as it is. Integration of e raised to minus st is minus st divided by minus s. Limits from 0 to a by 2 plus minus e as it is. Limits from e raised to integration of e raised to minus st is e raised to minus st divided by s. Limits from 0 to a by a to a by 2 to a. Now in these two terms take e common, because here it is a, it is minus into minus will be plus. We have e divided by 1 minus e raised to minus s into a. Remaining is, otherwise if you want take s is also common. This is minus into minus plus, therefore it is, otherwise I will write another step here. It is minus e raised to minus st divided by s. Limits from 0 to a by 2 plus e raised to minus st divided by s, because this minus get cancelled from this one, so that it is a by 2 to a. Now take s from these two terms. We get e divided by s into 1 minus e raised to minus s into a. Remaining is minus e raised to minus st 0 to a by 2 plus e raised to minus st a by 2 to a. Now we have to apply the limits. We have Laplace transform of f of t is equal to e divided by s into 1 minus e raised to minus s into a is same. Now we have to apply the limit. Upper limit is keep minus as it is. Upper limit is a by 2 here, therefore it will be e raised to minus s a divided by 2. Lower limit is 0, e raised to 0 is 1, therefore it is minus 1 minus lower limit, upper limit is a, e raised to minus s into a. lower limit minus, sorry, it is middle one is plus sign, e raised to minus s into a, that is lower limit e raised to minus s a by 2. Next is e divided by s into 1 minus e raised to minus sa. This is minus e raised to minus a sa by 2 minus into minus plus 1 plus e raised to minus sa minus e raised to minus sa by 2. See here, minus e raised to minus sa by 2 minus e raised to minus sa by 2. We have the two terms here, e divided by s into 1 minus e raised to minus s into a, 1 plus e raised to minus s into a minus, these are two terms, minus 2 e raised to minus sa by 2. I have written first positive terms, after that the negative one. 1 plus e raised to minus sa minus 2 into e raised to minus sa by 2. We know that, see here, 1 plus e raised to minus a sa minus 2a minus 2 e raised to minus sa by 2. See, we have one result, a square plus b square minus 2ab form, that is a minus b whole square is equal to a square plus b square minus 2ab. Here our a value is 1, b value is e raised to minus sa by 2, because when we b square should be e raised to minus a, because our b itself is a e raised to minus 2 minus sa by 2 into 2 means 2 get cancelled, remaining is only minus s into a. So we have to apply this result here. Laplace transform of f of t is equal to e divided by s into 1 minus e raised to minus s into a. This is, we have 1 minus e raised to minus as divided by 2 whole square, a square minus b square it is, then it is same. Next is, now I will take denominator term as, see it is e into 1 minus e raised to minus as divided by 2 whole square as it is, divided by s into, I will write this term as 1 minus e raised to minus sa by 2 into 1 plus e raised to minus sa by 2. Means I am applying here a plus b into a minus b. Consider this as 1 a square minus b square formula. It will be b square only when it is of the form e raised to minus 2as. To take here 2, just multiplying and dividing this term to 2, we get 2sa divided by 2. Therefore, it will be a square. I will write here e raised to minus sa is equal to e raised to minus 2sa divided by 2. It will be e raised to minus 2as divided by 2 means it is, it can be written is e raised to 2 into 1 minus, sorry, 2 into minus sa divided by 2. This is a square. So we have to change this term as e raised to minus 2as to get the square value. So I am taking, so I am multiplying and dividing 2 to this term. We get e raised to 2 into minus sa by 2. Therefore 1 minus is a square 1 plus b square, because a square minus b square formula is a plus b into a minus b. We have to use that result here. Just go through this calculation. You get 1 minus e into 1 minus e raised to minus as by 2 whole square divided by s into 1 minus e raised to minus sa by 2 plus 1 plus e raised to minus sa by 2. Here it is 1 minus e raised to minus sa by 2 whole square is there. One term get cancelled from this one. Only we have Laplace transform of f of t is equal to e divided by e into 1 minus e raised to minus as by 2 divided by s into 1 plus e raised to minus sa by 2. As by 2 or sa by 2 both are same. To get for further calculation, multiply both numerator and denominator to e raised to 4 as by 4. We get multiplying both numerator and denominator by e raised to as by 4. We get, see here our last term is like this. We can also calculate this further to get the required result. So that to get that required result we have to multiply numerator and denominator to e raised to as by 4. We get Laplace transform of f of t is equal to e into 1 minus e raised to minus as by 2 into e raised to as divided by 4 divided by s into 1 plus e raised to minus as by 2 into e raised to 4s divided by 4. As divided by 4. We get a into e raised to as divided by 4 minus, bases are same. When we add these two powers we get a minus as divided by 2 plus as divided by 4. When we take LCM we get e minus as divided by 4. Therefore it is e raised to minus as divided by 4. Same as denominator terms, e raised to as divided by 4 plus e raised to minus as divided by 4. Similarly here also we have to use the hyperbolic results as in the last video. We are using cos h80 and sin h80 solutions. Here also same we have, that is sin h80 is e raised to 80 minus e raised to minus 80 divided by 2, and cos h80 is equal to e raised to 80 plus e raised to minus 80 by 2. We have to use these results here. This is L of f of t. Then we have L of f of t is equal to e into e raised to minus as divided by 4 minus e raised to minus as divided by 4. Means sin h80 form. We have 2 sin h80 divided by, for the denominator we get 2 cos h80. 2 get cancelled. E by s, sin by cos is tan h. Here 80 value is as by 4. It is as divided by 4. Since AT is equal to AS divided by 4. Here I am writing AT. Just you have to put AT as AS by 4 because in our expression AT value is AS by 4. So you have to use in place of AT here only. Just I am written AT here. But you can't write like this. Here write here only AT as AS by 4. We get Laplace transform of f of t is equal to e by s tan hyperbolic as by 4. This is the required result for the given f of t. See here, after this step I am multiplying numerator and denominator to e raised to as by 4 because I have this result, that is L of f of t is equal to e by s sin h a by sin h as by 4. Just you have to check when we get this result and what we have to multiply or add or subtract or anything to this term to get the required result. Just you have to multiply numerator and denominator to get this result as as by e raised to as by 4. When you people cleanly observe this result, means this one, you get on a small trick, means what we have to multiply to this term to get the required result. In the same way, solve this one, you get a clear idea about this previous example.